Welcome to the Myrna Method live stream. I'm registered dietitian Myrna Haag. My goal is to bring you impactful nutrition information that can significantly change your life. In this video, we're going to talk how liver implicates insulin resistance, type 2 diabetes, how liver is involved with dumping sugar in your blood, and how this can either cause total mayhem or in some cases could actually be of benefit. So Sam, if you're ready, let's take it down. So the hidden pathway of liver sugar, I guess that's kind of a dumb title, right? But what I'm saying here is that there is this underneath biochemistry that the liver's doing all the time for us, that a lot of times we don't realize with the foods we eat and what we're doing. We're either making it worse or actually depending on it for more positive things. So in this video, I want to drive home how this is going to be implicated, again, with type 2 diabetes. There's a couple videos I did in the past. Sugar does not cause diabetes. A lot of people get super confused there. And we're basically told that it's sugar and it's insulin. These are just culprits, right? The root cause of type 2 diabetes, which we're going to talk about in this video because it's also implicated with fatty liver and what the liver does in regards to dumping sugar in the blood. So this is all swarming around, all in the same little cargo basket when we're looking at how sugar is implicated. And what I really wanted to make sure people understand, it's not the root cause. And should you cut carbs? That brings me to what I see a lot of people when they come into my office always tell me that they're eating healthy, they're dropping out their carbs, they're restricting their carbs because the liver, as they tell me, has the ability to make sugar and make it available for them. So why eat carbs? Why even eat any sugar at all? Because it's so implicated with raising insulin and causing so many problems. And this is a huge confusion. And I hope this video will help straighten it out. So a lot of people believe that eating carbs doesn't need to really be necessary. And we're probably healthier by not eating them. So let's talk about the liver, because the liver is a really good guy in this picture because it does help feed the blood sugar with sugar. It does help feed the blood with sugar when there's no sugar available, like you're on a low-carb diet, or maybe you've just exercised and you've really taken all the muscle sugar out. The liver will always be there for you to dump sugar in the blood. And it does it in 3 different main ways, and we'll go through each one. And then we'll talk how this is implicated in your real life scenario. So when we talk about glycogenolysis, we are talking how the liver can store sugar. It's called liver glycogen. And what's unusual, the different types of sugar, is fructose, and I often think of high fructose corn syrup or just the fruit sugar, right? Sugar in fruit. And alcohol, these 2 types of sugar, fructose and alcohol, they take a direct route to the liver and they're stored as sugar. So they don't go out the way the other carbohydrates do, the other sugars. They go out from the intestinal tract into the bloodstream. But with fructose and alcohol, it first goes to the liver and the liver stores it as sugar. And then the liver can deliver it from that point. And why is that important to know? Because if you're having an excess of glucose and alcohol, and the liver has had its full capacity, and that's only about 50 grams. And what does 50 grams mean? I'll kind of go through it with some labels. But a couple glasses of wine, some mixed drinks, eating a diet of high fructose corn syrup, or just eating a diet that's relatively healthy, but it's just too much wine or maybe too much fruit. This can cause your liver to fill capacity of glucose. It's going to be 50 grams. And then anything in excess is going to be stored as fat. triglycerides. So fructose and alcohol really default once you meet the capacity of the amount of stored sugar that the liver can fully hold. It's then going to be changed to fat. And that's where we can get fatty liver from drinking too much alcohol, or doesn't need to be non-alcoholic liver disease, can be just from eating too much fructose. And that was the big problem with the high fructose corn syrup, is this directly goes to the liver and can contribute to this. So the liver has the ability to store its own capacity of sugar. Also, the muscles do this as well. So you have liver glycogen and muscle glycogen because the liver wants to have that storage of sugar so that it can feed the brain in case of emergency, because the brain also needs sugar. And when you're on these really low carb diets, we have to make sure that there is adequate blood sugar. Super important. People don't understand that. The liver is going to be the fall guy in this case. So let me just give you some food labels in regards to these fructose when you think of fruit. So when you see a food label, in this particular example, it says 15 grams of sugar, and we know it's from fruit. Half of that is going to go to the liver in the form of fructose, and the other half is going to go out through the gut in the form of sucrose. So when we look at fruit in general, it's going to be about a 50-50 deal. Because fruit isn't all fructose. It's not just all fruit sugar. Of course, high fructose corn syrup can be 100% fructose, which is why that's such an issue. So when you look at a label and you see something that says sugars, for the most part, you can divide that by 2. And you know half of that's going to the liver. The other half's going to go out through the gut like normal other carbohydrates enter the bloodstream. And why do I mention this? Because on average, for a given day, the liver stores about 50 grams of sugar. And then anything over that, still going to come in as fructose, still going to come in as alcohol, but the liver's at full capacity of 50 grams, and then it's going to start storing these sugars directly as fat. You're going to actually get an increase in your triglycerides. And you know that word because you've probably seen it on your lipid panel when you go to get your cholesterol test. And these high triglycerides, typically we see somebody with high triglycerides, we know that they're just probably eating too many processed foods, but it's highly connected to insulin resistance, which we're going to talk about that. So when you look at a situation like this example, it would take a lot of Dannon yogurts with fruit to get up to 50 grams. But not so the case if you're doing a big bowl of fruit on top of that, and then you're doing a couple glasses of wine, and then you're just eating crackers, you're not looking at labels, it's got high fructose corn syrup. So you could easily get to that 50 gram amount without even thinking about it. I also want to show that a lot of times people don't understand just because something says carbohydrates, this doesn't mean it's going to the liver to create fatty liver. I'm going to go back to the example where you have a situation with carbs that break down everything else that's not fructose or not alcohol. It goes straight into the bloodstream. So when we look at these food labels and we can see that it says sugar 2 grams, well, okay, maybe 1 gram is actually going to the liver. So you'd probably have to eat a whole loaf of bread to have the triglycerides increase. So it's not just eating carbs that do it, it's eating the fructose and the alcohol. And a lot of times we can look at carbs. In this example, this multi-grain bread has got 26 grams of carbs, but only 1 gram of sugar. So there's a big difference in the type of sugars you eat and whether they're going to be stored in the liver with sugar and turn into higher triglycerides. So let's talk about when the body breaks down sugar and puts it in the bloodstream. 2 ways it does it. The liver. So the liver can always dump sugar in the bloodstream, and also from the foods you eat, the starches, right? All the other carbohydrates that are not fructose or alcohol are going to just go right into the bloodstream from the intestines. The body doesn't know if this sugar came from your liver or came from the gut. Once the glucose is in the blood, it's glucose, period. The goal is that the glucose can get into the muscles. Now, once the glucose is in the muscles, that glucose cannot go back out. In the liver, we can have a situation where the liver can bring the glucose in, take the glucose out. So the liver is really awesome regulator of blood sugar. But the main point, glucose is glucose. Once it's in the blood, the body doesn't know if it came from the liver or if it came from your gut, from the foods you ate, from the carbs. So let's talk about the liver being able to make sugar. And this is really the big, claim to fame that people tell me that they can do these low-carb diets. They don't need to worry because, didn't you know, Myrna, the liver can make sugar from non-carbohydrate sources. And yes, it can. The liver can make sugar from amino acids. These are proteins that you eat. So yeah, you're on a all-meat diet, carnivore diet. The liver can make glucose from protein. It can actually make glucose from fat cells because the fat cells store triglycerides. It stores these fats, and part of those fats, the glycerol backbone, gets released when you break down fats, and that can be stored in the liver as sugar. So the liver has the ability to make sugar and put it back in the bloodstream. It's like an open door. And also lactate. So when you're out there exercising and you build up that lactic acid, the body will recycle that to the liver and put sugar back in the blood. So this is a great thing that the liver can do this, because in times of deprivation, in times that we don't have access to sugar, the blood can get access. And one of the reasons why it's so important is because muscles require sugar for superactive energy. So when we were in the wild, the liver took care of us. When we were in the hunt, or maybe a lion was chasing us, whatever the case, we knew that the liver was going to cover it. They were going to make sure there was enough sugar in the blood to help out in emergency situations for the times that it wasn't available through the diet. So there's hormones that actually trigger the liver to release the sugar. And the lifestyle situations that cause this are going to be fasting, low blood sugar, and I put to the right some of the hormones that trigger that, acute stress, exercise. So we have these catecholamines, we have these cortisols, the glucagon. These are all hormones that when these lifestyle situations occur, the body will trigger the liver to dump the sugar in the blood. Chronic stress, fear, anxiety, fasting, all of these release hormones in the blood that trigger the liver to release sugar. And this is a good thing because the body can use the sugar to do other metabolic processes. In the wild, it was designed that way because if you got stressed, if you were in a situation, you had a fight or flight scenario, which is why you would typically have these hormones circulating when there's fear and anxiety. Well, that meant your muscles were going to have to get out there and start moving because you were going to either be fighting it or flying away from it. And this is why the liver dumped the sugar, so that it could immediately be pushed into the muscle for immediate, vigorous action. And that's one of the reasons why stress hormones can trigger weight gain. So let's get right into the biochemistry on how this works in getting sugar into the muscles and into the other organs, the brain, areas that really are wanting the sugar. This is why the liver is doing what it's doing, to supply these other organs with this glucose so that positive things can occur. When you have glucose enter the blood, either from carbohydrates, right, from your breads or your starches, or maybe you got stressed and there's a lot of hormones circulating, the liver's dumping a bunch of sugar, or, maybe you just didn't eat enough carbs and the liver's going to dump a bunch of sugar. Maybe you exercised excessively and the liver's going to dump a bunch of sugar. Maybe you have a lot of fear and anxiety and the liver's going to dump a bunch of sugar. Regardless of how much you eat, the liver's going to always be there for you during stress. What happens is that sugar rushes to the muscle, knowing that you're going to probably do something to fix the stressful situation, whether you're running or fighting from it. And the goal is that the sugar gets inside the muscle. Also, the sugar wants to get inside certain neuronal cells in the brain. And in doing that, the body releases the hormone insulin. And insulin's goal is to attach to a receptor site that sits on the muscle. It's called the insulin receptor site. And when insulin attaches to the receptor site, it talks to a messenger, which talks to another messenger, and allows the transporter to the surface of the muscle cell. And that's what allows the sugar into the muscle. And at that time, sugar binds with water. I showed it in another slide here. For every gram of glucose, we have 3 grams of water. So once glycogen is in the muscle, we are hydrated at a cellular level. Also, glycogen in the liver also has hydration. Provides hydration. So when you take a lot of carbs out, you're going to take a lot of water out, and this will cause a lot of quick weight loss, which is a big proponent for people doing low carb diets. Because they lose the carbs, they lose the water. So we go back to our example. When this takes place, everything works like it should. So there's no insulin resistance in this case. Even the liver can dump sugar. Every unit of sugar goes into the blood, and it's hopefully going to all the places it's supposed to. And when you're young, this isn't a problem. We know, because you give a kid sugar and he's going to bounce off the wall. He's got all this energy. Maybe a couple hours later, he's taking a nap, because when you have a lot of glucose in the blood and you get a lot of insulin, the backlash can be a couple hours later. You're going to be more tired because you have all this insulin in the blood, but that's it. You're going to be fatigued until you start getting to be over the age of 35 and you start developing insulin resistance, type 2 diabetes. This is when that insulin receptor site becomes clogged. It's disabled. And this transporter cannot come to the surface of the cell to allow the sugar in. This transporter cannot allow sugar in, which means the sugar builds up outside the muscle cell. When the sugar builds outside the muscle cell, more insulin is released into the blood. Now you're hungrier, probably you're grumpier, because your blood sugar is going to drop. Because what's going to happen is this insulin is going to attach to your fat cells, and this is going to allow the sugar that was meant for the muscle to be put into fat cells. So you're going to get fatter the more insulin resistant you are. The more these receptor sites are disabled because you can't get the sugar in the muscle to be burned for fuel, it's going to be put in the fat to be stored as fat in the fat cell. This is insulin resistance. And so maybe only 10%, maybe only 15% of these receptor sites are clogged, because you're only 30, 35. And then by the time you're 45, by the time you're hitting menopause, right? Because a lot of people associate that they're gaining weight in the midsection, because when the sugar gets dumped into the fat cell that was meant for the muscle cell, it's going to be in the midsection. Also, the liver will have the same problem, insulin resistance in the liver, just like with the muscle. So the liver will become more fatty as well. But the thing I always talk about that I think a lot of people aren't talking enough about is that when you get this situation of these excess fatty acids, where are they coming from? Well, maybe you're just too fat, or maybe you're fasting. Maybe you're doing a lot of fasting and you're having your fat cells be really good at releasing fatty acids into the bloodstream. Because a lot of people think, oh, if I fast, it's really good because I'm going to be taking all these fats from my fat cells. Well, if you're not really losing weight and you're just dropping your body fat, and especially if it's getting down to too low of a level, what I have found with patients is this creates a scenario of a lot of excess fatty acids in circulation, also combined with a low carb, high fat diet. Because now you're getting a lot of fats from your diet, you're getting a lot of fats from fat cells releasing fatty acids, and these excess fatty acids accumulate in places they shouldn't, such as muscles and in the liver. And this causes a situation that destroys or disables those insulin receptor sites. And this also changes when this happens to a type of fat called a ceramide. These ceramide fats can also circulate in other parts of the body, and they can damage healthy tissue. They can damage livers. They can liver tissue, pancreas, contribute to type 1 adult onset diabetes, heart disease. These ceramides are not your friend. And this is all because we do not understand how to eat properly. This is all because we're doing a diet that we believe that we can eat protein, fiber, and carbs however we choose, right? We're going to do a high fat, low carb diet, giving no attention to how the body actually works in regards to nutrition. So in this case, this whole scenario is called insulin resistance. It starts out with maybe 10 or 15% disabled, and just give it time, because in about 10 years, you're going to get prediabetes, because you're going to have maybe 30 or 40, maybe 50%, and then we're going to start to see a lot of sugar in the blood, and this is what we're seeing as an epidemic in our country. And the ceramides that are caused from this also cause other issues in the body, health-wise. So, long-term, high-fat, low-carbohydrate, keto diets lead to this metabolic syndrome, which is type 2 diabetes, dementia, cardiovascular disease, obesity. This is what increases the risk for type 2 diabetes. And in this study, they show in this particular study, long-term ketogenic diet causes glucose intolerance and reduces beta and alpha cell mass. This is all dealing with the pancreas. That's where these beta cells are coming from. So in this particular study, it talks about a high-fat, low-carbohydrate keto diet that are typically used for weight loss, for short-term results, because remember, when you take out the carbs, you take out the water, you can easily, on a low-carb diet, be sustaining 10% less body weight because of dehydration at a cellular level. By the way, eat a potato and you know what happens. You're on a low-carb diet, you eat a potato and you gain like 3 pounds. Well, you're not really gaining 3 pounds, you're gaining water. You're rehydrating. It also, more studies talk about how low-carb diets for weight loss. Again, this is the big, benefit of doing these low-carb keto diets, because there's no insulin involved. People feel like they're really, hitting the lotto here. And their big excuse is the liver will just put, sugar in the blood and everything's going to be fine. But it actually contributes to more fatty liver disease. And what are the culprits for that? Elevated triglycerides, excess fatty acids, and we're going to see more ceramides in circulation. This is all part of fatty liver disease. And fatty liver disease is a disorder of insulin resistance. Insulin resistance promotes triglyceride accumulation. Triglyceride accumulation promotes insulin resistance. So we have this big hot mess that most people don't even realize they're setting themselves up for. And I think the biggest culprit, a lot of this, is that people are just trying to lose a few extra pounds. Understanding that losing weight doesn't always mean you're losing fat, right? I always talk about that in the podcast. This study here talks about ceramides' role in liver disease. Early stages of alcoholic and non-alcoholic liver disease leads to the accumulation of lipid, which is just another word for fat, droplets in liver cells. And this will also upregulate these fats called ceramides, because the fatty acids differentiate into a type of fat called a ceramide. And these ceramides are absolutely the fats that are involved, the culprits for heart disease. They're atherogenic. They can cause plaque on arteries. And, we're not really measuring them, but they are occurring. And that's why there's such a high association with type 2 diabetes, insulin resistance. I see it with my patients. They get the prediabetes, the insulin resistant, and sure enough, we're seeing elevation in their lipid panel. Their cholesterols are starting to go up, and they never had a problem before. It's like, well, everything was fine. It's just, I turned 55 and it seems like I'm falling apart. Well, this was probably occurring a decade before. Bottom line, the way we fix this is we learn how to eat your macronutrients, protein, fiber, carbs, and fat, at the amount that is required to keep the body healthy and balanced. And I talk about balance because in the Myrna method, when I'm coaching my patients, people are very confused with the difference between eating healthy, which is, a lot of foods can be healthy. Avocados and nuts and seed oils to some degree are healthy. Eating balance is knowing the ratios for these macronutrients. Totally different. And it's the balance that causes the mayhem, the imbalance, not understanding that no, you can't just decide because Sally down the street did a diet, a keto diet, and lost all this weight. She probably lost a lot of water weight. I'm not even going to say she possibly did lose weight, but it's not sustainable because the body cannot sustain a diet that's not balanced. There's all these triggers that I'm not going to talk about in this podcast. I talk about it in other podcasts. The body doesn't do it. It's not sustainable for a reason. So the idea is that, look, protein, fiber, carbs, and fat, the body wants you to maintain a certain amount. On average, I have many podcasts. I go into all the detail. This one, I just wanted to bring home the whole liver sugar dump. And by the way, I also want to mention that if you're a diabetic and you get stressed out, you don't even have to eat anything and your glucose can be elevated. Same with insulin resistance. Because of the stress, they can trigger the dump in the liver of the sugar. So I have diabetic patients that can even go exercise and get an increase in glucose. Get stressed out, not eat anything. And if this over here is all gunked up and you have insulin resistance, it feels like you don't really know why, but you're just gaining weight. And you swear you're not eating that much more. And I believe you. You're probably not. But you're not eating balanced. You're not understand there is a way to regulate what you eat to reverse this metabolic mayhem. Ideally, rule of thumb, for most people, protein grams, anywhere from 60 to 140. Fiber grams are going to be anywhere from 40 to 70 grams. Carbohydrates, yes, you need them. but you want to make sure that you eat them with protein and fiber. That's why they're called net carbs, because when you bring the fiber in with the carbs, you slow the entry into the bloodstream. Makes a huge difference when we're dealing with insulin resistance. A lot of sugar in the blood isn't a good thing. Even though it's not the root cause of the disease, it'll cause total mayhem and increase the storage of fat, because the sugar, if it's not going in the muscle, it's going into the fat cell. And then, of course, you want to make sure that you're getting the fat grams at the amounts they should be. And I think the biggest culprit is that there's seed oils in everything, chips, everything. You go to a restaurant. I'm not even sure you can go to a restaurant and get a meal under 80 grams. That's just for one meal. And for most of us, that's probably what we need for the day to be at 25 to 35% of our calories from fat. So this is an area in dietetics that I see as a big issue. We're not following a balanced diet, leading to fatty liver disease, type 2 diabetes. I have a book. You can get it on Amazon, Kindle, $2.99. As far as I'm concerned, that's a no-brain buy, right? I talk about the science behind how to eat. It's not foodless, but it's understanding food has a metabolic purpose. When you get it right, your body is humming. Most diseases, metabolic diseases, can be reversed, definitely improved off most medications, because diet is the number one reversal for most of these metabolic diseases. Also, you can visit me at Myrna Method. I have a membership that I work with people, and this is all we do is just learn how to balance our diet. So Sam, how are we doing on the chat?
We're doing good. All right.
Okay, awesome. Don't forget to like and subscribe. And next week, I'll see you guys with another great topic to improve your life in nutrition.